The term intelligence was defined on numerous occasions. There are hundreds and thousands of authors, and each has a definition of intelligence. All throughout their process, the physiology, biology, neurophysiology has also been developing. Giving yet another definition of intelligence is not very productive, I think. Still, this is a question of interest for many people. Over the last years, newcomers to AI, to AGI, offer their own definitions and concepts about intelligence, and also, strangely enough, old-timers as well return to discussing this topic. In particular, last year, in the Artificial General Intelligence Journal, an article was published on defining artificial intelligence by Pai Wang that discusses the ideas of Pai Wang from 25 years ago. The article deals with the ability of artificial intelligence to adapt to a new environment. There was a special edition for 100+ pages. Not bad for a rusty topic. It's all good and fine, but discussions and debates continue. Last year, I was involuntarily involved in a discussion about artificial intelligence with people I didn't know, and I had to give my opinion, my take on that. I'm not going to give you my definition of intelligence, but I'll try to smooth out the differences between different opinions. I hope they will not cause any more aversion. There are all kinds of definitions. Some are good, some are bad. There are good examples of other definitions that showcase that. We have definitions of such non-trivial terms as temperature or variability. Pai Wang rightly says that definitions are of different kinds, and it also stokes further discussions. Intelligence is just a word. We can use that term to describe the intelligence of people, aliens, robots, even the ocean Solaris. The ocean is from sci-fi, but it's still another use of that term. So intelligence is not just human intelligence. Otherwise, the non-human intelligence would be an oxymoron. We can also talk about spatial, linguistic, and even emotional intelligence. Clearly, speaking about self-consciousness, speaking about consciousness and spatial navigation would be odd here. John McCarthy defined intelligence as the computational part of an ability to achieve goals in the world. It says computational, but what it means here is that the physical force or speed can facilitate achieving certain goals, but does not mean increasing intelligence. Some would say that there's nothing in this definition about training, learning. Some may even say that intelligence is something completely different. I'm not going to defend this definition as something perfectly describing an objective phenomenon, but overall I think it reflects the practice of using the word intelligence pretty well. But on the other hand, it's not a definition at all. It's a goal. If we simply specify that we're talking about artificial intelligence and describe the class of systems to which we apply this term, that would raise fewer eyebrows. We can also add that this is about something we want a computer to do. For example, solve problems for us. That wouldn't, no one would argue with that. For example, I would really like a computer to solve problems for me. No one could object to that, I think. Some would like a computer to control a robot. I would like that as well. This is a subset of tasks, of goals and objectives that I could agree with. I won't say that something else should be desired from a computer in all cases. That would be ridiculous. We could also imagine that this is a description of intelligence. So if we add that to the definition of an intelligence as the ability of an autonomous agent to act in an environment, that could yield a lot of discussions and debates. Still, the definition of artificial intelligence as the ability of a computer to solve tasks, especially to deal with tasks that we don't know how to approach to, could be commonplace and could be agreed with. This harkens back to what Bertrand Raphael said. Why are solved tasks outside of the perimeter of artificial intelligence? Because we've already solved them? What about general artificial intelligence? One of the canon definitions, but maybe not the best definition of AGI, is proposed by Legg and Hote. They analyzed dozens of other definitions, and they came up with the following. An intelligence measures an agent's ability to achieve goals in a wide range of environments. I like it because it's very close to the definition by McCarthy. Other definitions are not that different, with different focuses on adaptability, various environments. There are definitions by Ben Goertel, and other researchers and scientists. I will probably make a reference to Marek Rosa from Good AI. The definition is still pretty much along the lines of what we discussed. There is an addition about the computation, the computational aspect. The main difference, though, is the variety of environments, the wide range of environments. What does that mean in particular? We're trying to say that the same computer system should be able to tackle tasks that we haven't yet resolved. Some would like to understand how the human brain works. Some are curious about problem-solving, task-solving by computer means. Goals and objectives can be different. With AGI, the objectives and goals can also be different. For example, there could be a lack of resources. Why shouldn't the intelligence tackle issues better with sufficient resources? Some say that systems operating in real world are better. They are not ideal, but they are operable. Still, in that definition, the desires, the expectations of artificial intelligence could still be objectionable. I think a good idea is the idea about the ability of intelligence to act with insufficient resources in a wide variety of environments. There is consensus, pretty much, about it in the AGI community. This is important. For each task, for each problem, a specialized solution could be found, could work better than a generalized solution. Those who used potato peelers know how convenient that is. I have other reports, other presentations about mathematical aspects, because that should be commonplace. The point is that for every task there is a specialized solver that is more efficient than other solvers at problems. What does that mean? There should be, and there is, chess intelligence, geometric intelligence, and so on and so forth. There is no conceptual difficulty with having a system with very powerful subject matter intelligence without any other types of intelligence. Or a system could be unable to solve a problem at a particular point in time. The word intelligence could also be questionable, but if we replace that with solver, that would be obvious and banal. Some could say that a chess solver, a chess intelligence, has nothing to do with intelligence. Maybe there is no solver, no general solver at all. There are just multi-tools. Still, it could be considered, and solving particular problems with specialized programs could be presented as deep transformation, building an efficient representation for a specific problem. During that transformation, structurally, you may be left with nothing from the initial program, which is why the specialized chess intelligence could not resemble intelligence at all. You don't even have to go to maths to judge that these solutions come from somewhere. They have to, a person, probably, who builds the intelligence. This process has been getting more and more automated and produces a better understanding of artificial intelligence and what that means. The resulting system has narrow AI, according to the McCarthy definition, but for its operation, general AI, AGI, according to Lega or Huta or anyone else, is not required. And intelligence is a multifold of all representations, of all projections. When people work with these projections, the narrow AI, they rarely venture into AGI. Understanding this moment is a starting point for developing or working in AGI as an independent, as a standalone area. Why not work in such intelligence that would not just tackle narrow ranges of problems, but also create efficient solutions that doesn't have to be architecture search, or 2ML, or method learning? These are steps in the right direction, and they could be described as AGI. But some rare or unique problems are better solvable with general methods than a particular solution. Even if there is an analytical solution, but we need to solve a problem just once for low dimensionality, it's better to use brute force method. Some in AGI are interested in only general methods. They are slow or optimal, or more approximated and slow. Depend on the goals and objectives. Some are interested in ultimate particular solutions, that is narrow AI, and all these groups debate among themselves. I think all the components should be of value, but that depends on what we need from the system. So we have a consensus in artificial intelligence that, based on theory and practice, narrow AI is built slightly different than general AI, maybe even very much different from AGI. There is good progress in developing specialized systems, but it gives very little to develop general systems. Do we need general systems if specialized systems yield good results already? It's an interesting problem. It's like asking, why do we need heavy machinery? AGI is the heavy machinery. It's going from manual labor to automated manufacturing. The bottleneck is a human now in those systems. In deep learning and artificial intelligence, we still don't have enough resources. When we say that we want a computer just to solve problems, we want AGI, basically. No matter what general systems we consider, they always have bias. It's mathematically unavoidable. Sometimes the bias is so strong that researchers and scientists don't consider certain classes and groups of problems because they are not intelligent. I don't know why, I don't know what the criteria are, but still, that's the case. Also, AGI represented in a robot. That could be a requirement for AGI, and also a reflection of the desire to just work in robotics. My opinion, and maybe my desire, rather, we shouldn't narrow down the range of problems. But then again, there's a question of how wide should the range of problems be for us to consider. Also, there is no consensus as to how artificial intelligence, general AI, should be. We only know what it shouldn't be. It shouldn't be a narrow AI. Still, I think there are certain conflicts that we could smooth out with regard to the goal setting and the methods. For example, we could underscore the methodologically important ability to tackle different problems. Could lead to a definition of artificial intelligence with regard to various environments, which means that an agent always acts in a new environment, which it has to adapt to. Some may say that this way we rule out the intuitively important things such as incremental or transport learning. Lang also objects to just taking a task, resolving it, and throwing it away. There are also questions about benchmarks and competitions. where using previous experience is needed in new environments with new problems. There are different accents, different aspects which lead to methodological differences. Those differences should be dealt with. Let's look at the formalization of Leg and Hutter through the coefficient of universal intelligence. This basically means that to evaluate AGI, we need to put our agent in different environments, this way zeroing it, basically. Doesn't that mean that an agent should solve a new problem, not basing on the previous experience? No, that's not the correct interpretation. The model of universal induction and the Alexey does not mean that there is an unlimited manifold of non-connected environments. It's a single environment. It just varies very much. The averaging is just about dealing with the perception of our world for a different agent. Clearly, there should be incremental transfer and lifelong learning. A lot of independent launches is the result of our poor understanding of the world. No one objects to having the basic machine in Alexey taking into account the specifics of our world. Should we work with this bias manually, or should we count on the system to identify it and deal with it itself? So we underscore the necessity for the system to be able to deal with a variety of problems, different problems, and there is no fallacy there. The definition is not ideal because since we are aspiring for the ideal, accurate definition, in the pursuit of all those things, we sometimes oversee the fact that different environments are just alternative models of the same world. There is no conflict, there is just a lack of precision in the definition. With McCarthy and Hutter, with their definition, nothing is said about how those goals are achieved. This could be a collective definition through reference to the manifold of purposes. If we want, we can also parameterize the agent and add the reference to the animal intelligence. The definition offered by Perivang, I don't suggest that as a definition for AGI, because that could raise objections for many reasons, but I hope that this sheds some light on how the accent on the wide range of environments does not conflict with the adaptability, the single world, the incremental transfer and lifelong learning. Thank you for your attention.